So we're back to the Fidelity 1000, and this time we're going to set up the IF of the receiver, the intermediate frequency section, the 455 kilohertz bit of it, using the sweep generator. So we're on test bench 3 here, so I'm having to use a camcorder because there's no overhead video camera. So this setup, we have here a quartz lab radio telephone test set with a Farnell signal generator above. The reason that is the quartz lock test set doesn't go any lower than 88 megs. Well, because we want to only 7 megs, we're using an external signal generator. Above that we've got an oscilloscope, and above that we have a spectrum analyzer. Power supply, a relatively cheap little Chinese signal generator which we use for 10.695. I'll just zoom in on that, and we're also doubling up as a frequency counter because it has that facility as well, as you can see. Then moving across there we've got a trusted Farnell analog sweep generator. That only goes up to 2.2 megs, but we only want 455 kilohertz. So what we have done is, according to the service manual, which is there in front of me, we have got the sweep generator, and it's set up so that the first of the test prods there, can you see it just goes to the left of that tuning? No, I'll move over there. We're going to look at that one. This test prod is connected to the base of transistor 3, Q3. There's just a handy capacitor next to it, so we can hook the clip round there. So that's there, that's going to the sweep generator. The oscilloscope is connected at the other end, and just next to that tuning can, which is one of the ones we're going to be doing, is the connection to resistor 82. Now these resistors have got paint on for insulation purposes, so I always scrape away the paint just so we can get a proper connection. So we've got the generator there, and it's set up for 455 kilohertz, and that's showing on the counter there. With it being an analog instrument, if I'll just see if we can just get that a little bit nearer. That'll do. And that's what we have on the oscilloscope screen. Now I'm going to switch the sweep generator. It's generating 455 kilohertz. We've got a 1 millisecond sweep, so that's 100th of a second, isn't it? We're on 10% of the width, so effectively we're sweeping minus 50 kilohertz and plus 50 kilohertz. So we're sweeping from about 390 to 510. That's the plan, and of course it's set up as a sine wave. And you have this set as high as possible, the highest possible output from the sweep generator before the radio would overload. So there's no aerial connected. It doesn't matter what channel you're on. We're on channel 20 because it happens to still be on that from previous tests. We're now going to switch this to sweep, and when I do so, we've now got a totally different type of trace on the oscilloscope. Now then, you've got 2 coils here, which are numbers. Just look at the manual. You have got T4 and T5, and T4 and T5 are just under this wiring harness here. And what we do is to adjust these for the best possible trace on the oscilloscope. So let me just, this is adjusted correctly, so I'm going to unadjust it. Can you see we've got the symmetry gone totally out there? So we want the best possible sine wave. And then on the other one, again, we can make that look absolutely awful, and we want the best possible waveform. And that is it. With those 2 adjustments using the sweep generator, that gets the IF spot on. Because remember, this type of radio doesn't have a clever demodulator chip like most sets do, like the MC3357 is. this just uses, if I remember rightly, it just uses a double balanced diode detector. And interestingly enough, I seem to also recall the squelch is AM on these. So the level squelch just has an AM detector and it works that way. So that has now set up using the sweep generator. There's no other method, the IF on the Fidelity 1000. Okay, so now we're back to the normal tuning of the normal part of the receiver. I'll stay on this test bench, seeing as we're set up on here. And to do this, if I can manage not to put my finger in the front of the lens of the camcorder, the normal part of the receiver is L1, L2, L3, T1, T2. Now on this test set, the cyanide meter, there's an automatic cyanide meter which is up here. Now I prefer to use one with a normal conventional needle type of instrument, but on this Farnell one it's digital, so I find it a bit more cumbersome. So what we're trying to now do is adjust the receiver for the best possible sensitivity. So there we are in L1. It just said 10.4 there. That's reminded me of saying 10.4 on the radio. And the next one, we've got a 1 microvolt signal at the moment. These radios are capable of being very sensitive. We'll just move to a different type of tool for those other two. I'm trying to get the lowest possible numbers on the cyanide meter. You can't do this by ear, you've got to use instruments. So that's wobbling about like that. As I say, I find it much easier to use one with a needle. What I'm going to do off camera is I'm just going to peak those for a second, for a third time, and then we'll see what sensitivity we can get out of it. Okay, we can still hear we've got the tone. If I just switch the carrier off and back on again, and we've got the sensitivity at 0.25 of a microvolt, which is absolutely excellent. Now what we're going to do is to put a 100 microvolt signal on, which is equivalent to S9. So we'll just get the dials in the right place. And that should read S9 on the meter. It reads plus 30, so we'll just drop that again and I'll show you that adjustment. It's SVR2, and SVR2 is the first one here to set the S meter up to S9. So that's what we will now try and do if I get the camcorder in the right place. Actually, it doesn't drop any further. Oh well, that's how it sets up. So it's a bit higher than I like. Let's put a 50 microvolt signal on, just see how that reads on it. That's one of the other standards. Yeah. Well, I'd say it's a bit of a generous meter. We're certainly not going to start modifying the radio to have it how we'd expect it to be. So that covers the receiver on a Fidelity 1000, but it's all lies on getting the IF correct with a sweep generator. So just before I leave this radio and we do an air test later on another day, what I'm going to do is I'm just going to put it on the aerial and we'll see if we can hear anybody swearing on. And there we have it receiving. It'll be Nottingham, about 35 miles away. We'll do an on the air test and do a proper demonstration another day.